What if I told you that the fundamental building blocks of mathematical space, points, don't actually take up any space at all? That they exist without size, without dimension, and without any intrinsic connection to anything else. And yet, somehow when we bring them together under a structure, they form the very foundation of geometry, calculus, and even acts as an inspiration or as an insight for our understanding of the physical universe that we're surrounded with. And today, we're diving into the paradox of nature of points, how they emerge from absolute nothingness and how they relate to space, and how mathematics bridges the gap between the isolated nothings to create the concept of continuity. We first start our journey with the idea of the void of quantity, or a mathematical point. At its most fundamental level, a point is an abstraction, a mathematical object without size, dimension, or physical presence. It does not take up any space, nor does have any inherent relation to anything else. Imagine a point existing in isolation. In its purest form, it is said to be independent, which means is a conceptual entity without any measurable properties that we can associate. But the moment we introduce another point, let's call those 2 points A and B, we now need a way to relate them. Mathematically, this means we need to introduce or define a space with structure, because without structure, the 2 points remain independent abstractions, but with structure and properties of the mathematical space, they become a part of the larger system where they start to dance and sync with one another, and therefore contribute to a space that allows for distance, order, and connectivity. Then it's time for establishing relations, using the properties of space, from absolute nothingness to structure. And what properties of space forces points to become independent? Well, to describe how A and B are connected, we introduce mathematical tools such as a distance function, which tells us how far A is from B, and a real number line where every point is always between two others. Introducing the mathematical density property of real numbers, between any 2 points, A and B, there's always another point. This density property ensures that any 2 points are connected and embedded within an infinite continuum of points in space. And the density property also guarantees that no matter how close A and B are to each other, there will always be infinitely many other points in between them. The concept of an infinite continuum serves as a common ground for every little individual set of points, allowing for the interdependence of points in a way that they interact within the mathematical space. As a result, the existence of points is intrinsically tied to others, and there is no true boundary between individual points. If someone were to introduce a minor shift to a function, it would manipulate the entire number set, which would create a shadow region of influence. And this illustrates a continuous connection and infinite nesting, or divisibility, since there's always another point in between 2 points. One can continue nesting points deeper and deeper. The more one zooms in on a point, the more points appear, revealing that a single point is a merely part of an infinite web of interconnectedness. Now there comes a deep question. What exists between 2 voids of quantity? If two points have no size whatsoever, no extent, then how do we transition from one point to another? How do we mathematically map from one nothing to another nothing. And this is where we're going to talk about the unbounded division and the continuum. If we were to take a segment between A and B, we can always cut it in half and then cut that in half, and so on forever. This infinite process of division is what determines the continuum of real numbers. If space is continuous, then every line segment in that space contains infinitely many points. And here, there's just some paradoxes that we could get to, such as the fact that each point has no size, yet together they fill space, and as a result, something emerges from nothing. But how? Well, because the connection between 2 points is not intrinsic to the points themselves. Instead, it is the structure we impose through metrics, order, topology, and functions that makes a collection of points into something meaningful. Points can never truly be alone. They are always part of something greater, simply because we define them to be. So as a result, mathematics has a way of turning the simplest ideas into the most profound mysteries. Points in this isolation, they don't have a point. They're completely meaningless. But with structure, they define everything. The paradox of continuity is that infinite nothings, when structured correctly, become something. They become the space we live in, the lines we draw, and the numbers we use and use to describe the universe. Now, so the next time you think about a single point, you're going to ask yourself, is that really nothing? Or is it everything? Thanks for watching.